Okay, so question 28. What reagents could be used to carry out the following syntheses? So all of these are starting out with an alkyne, and you're basically changing this alkyne in as many different ways as you possibly can. I'm going to go through four of the different subvariations here, and you can do the others on your own, um, but I'll just get you going in the right direction. So for all of these, I would, it's always good to either label or, if you have coloring possibilities, you can color carbons to make it easier to see where everything's going. The one thing to remember here is that this triple bond, you do have two carbons, one that's orange, one that's yellow, the way that I've designated it. So yellow would be here, and then yellow would be here, and yellow's here, and then yellow's here. And then we've got orange going around all of these guys, 1, 2, 3, and 4. Okay, so notice that what we're doing is we're not tacking on any other carbon. All we're doing is we're playing around with this triple bond and adjusting it very slightly in different ways. Okay, so let's start with the easiest one. The easiest one is going from an sp hybridized carbon to an sp3. So what we're going to do is change this triple bond into a single bond. So the reagent for this is actually pretty simple. What we're going to use is hydrogen gas, so H2, and then palladium on carbon. Okay, and overall this is going to be a catalytic mechanism. So you only need a tiny little bit of palladium and this hydrogen gas. Okay, and remember all of this palladium on carbon means is that the palladium metal is adsorbed onto carbon. So usually this comes in small percentages of palladium to carbon, just so you can handle it really easily. Okay, so let's go to the next one. What we have is we have a triple bond and we're going to a double bond. What we're doing here is we're also adding on another atom. So here, remember that we have a hydrogen attached to this yellow carbon. And at the end of the day, what we did for this one up top is we ended up adding 1, 2, 3 hydrogens. 1, 2, 3, and 2 more right here. Okay, so this one right here, let's go ahead and actually redraw that. This was our original green carbon, and so that original green carbon is still here in this product, and then we tacked on 2 molecules of H2 gas total. Okay, so keeping that in mind, we still have one original hydrogen, um, and we're going to have one original hydrogen here, and we'll have an original hydrogen over on the yellow as well, probably. Okay, so going back down to this question again. So what we've tacked on is not just a bromine, but we've also tacked on another hydrogen. Okay, so the reagent that you'll need is buried in this information. So the reagent that we're going to end up using is HBr. Okay, so this is just another addition mechanism, and so what we're going to do is you'll have to remember here that you can actually adjust how many different additions you have. So if you added 2 equivalents of HBr, you're going to end up having 2 different reductions. But right here, if we want to have just one reduction from a triple to a double bond, what we're going to add is just one equivalent. So just one equivalent of HBr, and we'll get this HBr addition to the triple to give you the double. Okay. All right, so now let's go from our triple bond to our epoxide. So remember here, what we're wanting to form is an epoxide, and the way that the reagents that we use for that was that MCPBA reagent, so MCPBA, all right, so it's a peroxy acid. But remember that in order to get to the epoxide using MCPBA, you had to have an alkene. Okay? So what you could do here is that you have to remember that you need that alkene and you don't have the alkene. So this is actually a two-stepper. So the second step is actually going to be that MCPBA. First step is going to be really easy. We can convert the triple bond to a double bond, preferentially without going all the way to the single bond, using a couple of different reagents. And in this case, since stereochemistry isn't designated, we'll just go ahead and say we'll use H2 gas, and we'll use our Lindlar catalyst. So our Lindlar catalyst, again, is that poisoned version of the H2 palladium on carbon that ends up stopping at the double bond. So for the first step, step 1, we'll stop at the double bond, and then after we have the double bond, we can go ahead and reduce even further to the epoxide using the MCPBA. Okay, so this is just a little bit of a warning that you can potentially have 2-steppers, 3-steppers, multiple steppers for this kind of question. So keep that in mind. Okay, so then the final fourth subdivision or sub-question is that we're going to end up forming an aldehyde from an alkyne. And this reaction's a little bit more difficult to see right away what's happening. You have to remember that we have only really talked about one way of how to get aldehydes, and that's from the alkynes directly. So in this case, we have to remember that we don't ever form the aldehydes directly. What we do is we end up forming an enol that will tautomerize to the aldehyde. So what we have is we'd have to end up starting out with something that looks like this. Okay, so here's our enol, and if we wanted to put everything where it was, this would be the yellow carbon, and this would be our orange carbon. And again, what we'd have happen is that this enol tautomerizes preferentially up to the aldehyde. So what you have to ask yourself is, how can we add hydroxide to the yellow carbon preferentially over the orange carbon? Because if we end up adding the alcohol, or not the alcohol, the oxygen to the orange carbon, we're going to end up getting a ketone instead of an aldehyde. So here you have to think Markov-Nikov, anti-Markov-Nikov. So this is going to be a little bit more difficult way of, a little bit, two or a couple different steps that you have to do in your head. So you can use an anti-Markov-Nikov reagent, which in this case, just to be simple, we can say this is the 9BBN. Okay. And as the first step, so this is the sterically encumbered boron reagent. So we're going to do our hydroboration, and then we're going to do our oxidation. So the second step is going to be hydrogen peroxide and hydroxide. Okay, and with these two steps, we'll end up forming the enol, which will then tautomerize up to the aldehyde. Also, if we didn't utilize 9BBN as the reagent that's going to be structurally encumbered, you can also use dicyamylborane or DSB as we've described it in class. So either one of these two reagents, 9BBN or DSB for dicyamylborane. Okay, yeah, and that's it. Moving on to the next question.